Hi everyone, welcome back. Video number 2 on ratios. Let's look at a bit harder and a bit more tricky, what normally mucks people up. I've written over here 3s and the 7s. So if you really can't do your times tables and you're struggling with them, you can write down that we've got 3, 6, 9, 12, 15, 18. You can write some of them down. You could keep going and write down more if you wanted just to keep adding lots of 3. And the one that really mucks people up is a lot of people do not know their 7 times tables. You got a 7, if you add another 7 you get 14, if you add another 7 you get 21. So there are ways around, if you don't know your times tables, if you can quickly write these down on your test paper, if you're not allowed to use a calculator or a set of times tables on the sheet. So you could add another 7, you could add another 7, you can keep adding lots of 7 and see what numbers you can come up with. So as long as you're careful on that, you can get around not knowing your times tables. So if I look at these two here, and I want to simplify them, that's even. So I could halve that to be 3, but then when I halve that, it doesn't become a whole number, it becomes a fraction or a decimal. So one of the things that gives it away is the fact that they're not both even is a common thing. So if I want to have students, and just make it a little bit harder but not too hard, if I use the 3 times tables, it mucks up a lot of students, including high-level Year 12 students who just get it wrong. If I really want to muck people up and can make it more challenging for them, I just have to make it 7s. It's one of the things that really just causes people a problem. Now, go back to what we're doing here. If I divide that by 3, all I'm saying is how many 3 times does 3 go into 3? Or how many 3s will go into 3? And it goes once. If I go 3 into this one, I've then got to go 3 into that one. So how many 3s into 6 will go twice. Now, sometimes for some students, I like to write, especially in a different colour, and we're going to go divide by 3 on that side, and if I go divide 3 on that side, I'm going to go divide 3 on that side. And there's some students that really helps, but we'll have a look and see what's going on. So both of these are divisible by 3. Don't like to talk about so much divisible by 3, but 3 goes into them. Because if you go over here, here's our 3s, 3, 6, 9, so 9 is the third one. So we've gone 3, 6 and 9. So 3 and the 9 goes 3, and the 3 and the 3 goes the 1s. So of course, again, if I make myself a bit of room, I can go and write divide by 3, and I can write divide by 3. I'm not going to keep writing that for the moment, but as long as you've seen it a couple of times, if you want to do that, it is helpful to a lot of people. So 9 and 12, 3, 6, there's a 9, and there's the 12. So they're in the 3 times tables. If they're in the 3 times tables, I can say how many 3s in the 12. If you didn't have it written down, you can sit there and go 3, 6, 9, 12. So that becomes a 4. And then how many 3s in the 9, and most should be okay, but some people aren't, and they have to go 3, 6, and 9, and they go 4 to 3. Now we can halve the 4, but if we halve the 3, we get 1.5. So they're the lowest numbers, the smallest numbers we can get without going to fractions or decimals. I could even divide that by 3 and get 1. But the trouble is, when I divide that by 3, I actually get 4 over 3, which mucks people's brains up. So there's a few of the 3s. Now I'm going to talk about the 7s. So your 7 times tables. So that's 1 7's are 7, 2 7's are 14, 3 7's are 21, and you can keep going on with it. So how many 7s will fit into 7? A lot of people just don't see the 7, so I nag about it a fair bit and keep coming back to my classes and go, okay, they're both in the 7 times tables, you can see them over there. They're both in the 7 times tables, you can see them over there. And they're both in the 7 times tables, you can see them over there. So it's getting people used to it, especially if they really don't know their times tables. I reckon a lot of people that do, they still struggle with it. How many 7s go into 7? Once. How many 7s go into 14? Twice. You can see it's a second number here, so it goes in twice. How many 7s go into 14 again? That's a twice. And how many 7s into 21? 1, 2, 3. And that's as simple as we can get, or the smallest numbers we can get. When we say simplify, the smallest numbers we can possibly get. Next one, same numbers again. 7 into 21, 7, 14, 21. So that goes in 3 times. And then how many 7s go into 7? We've got just the ones. Now a couple of tricky ones, just to go a step further and see what you can do with them. What is not specifically in what I wanted to show here was this is about 3s and 7s. That is divisible by 3, and that is divisible by 3. So if I wanted to, I can go to 3s, but there's an extra thing here. That's even and that's even. And most people can go divide by 2 quicker and easier than they can go divide by 3. So just want to show you for a moment. If I halve the 2, I get the 1. If I halve the 4, I get the 2. Now, how many 2s in the 18? You can sit there and go 2, 4, 6, 8, 10, 12, 14, 16, 18, and you get the 9. So what it's done, by halving both the numbers, these have become much smaller. So one of the powers, or the really incredible things about halving, is it makes all your numbers smaller, which makes life easier for your mental arithmetic. Now you can look at it and go, we've got 9 and we've got 12, which are on the 3 times tables. Now 24 and 18 were on the 3 times tables, but we've just made the numbers easier. 3 into 12 goes 4, 1, 2, 3, 4. 3 into 9 goes 3, and our answer, the smallest numbers we can get are 4 to 3. So now we'll go this one here when the 3 times tables get bigger. They're not even, so it can't be 2 times tables. This one ends in a 5, but that one doesn't end in a 5 or a 0, so it can't be the 5 times tables. So I keep talking about what mucks people up. Now, by the way, there can't be 4 times tables, because if the 2 doesn't go into it, the 4 won't go into it, because 4s are also even. So we don't have to worry about 2, so you also don't have to worry about 6. So I keep talking about these numbers all the time. 2, 5, 4 and 6. So if you look at just counting through your normal numbers, 2, after 2 comes 3. This one does turn out to be 3s. So if 2s don't work, they did on this one, and then the 3s would work. So the next number after 2 is 3. So I can go 3 into 27. 3 into 7 goes, there it is there, and you can work it through. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 3 into 15 goes 1, 2, 3, 4, 5. And again, we've gone as far as we can. They're the smallest numbers. That's divisible by 3. 3 goes into it, but 3 doesn't go into that. 5 goes into that number, but 5 doesn't go into 9 nicely. It does go as a fraction or as a decimal, but not nicely. So the main numbers we're going to look at all the time, and I keep nagging about, are 2, 3, 5 and 7. They're the numbers that we're looking to divide by most often all the time. Now, by the way, they are what we call, in case you've forgotten, you want to remember, some people like to know that they're called prime numbers. So we're actually dividing by our prime numbers. Not that it's always prime, but they're the best ones to start with first of all, to make sure that we've got down to the smallest numbers what we can. So I hope it helps. So that's with 3 and 7. Next would just come some more complicated ones where I make the numbers worse and maybe make them divisible by 10. So if you're enjoying them, please just let your friends know, and if you press like and subscribe, it just helps by pushing it further up the list for YouTube. Thank you.